All right. Most of us have gone down to SeaWorld or driven the I-5 southbound and come to a nice open area known as San Onofre. Now, as you pass by, as you're going southbound, you look to the right, going, all right, there's two big, giant, concrete, dome-shaped objects, and there's the power lines coming out of it. Okay, no big deal. Have no idea what it is, but all right, let's keep driving down. And most of us, until recently, gave little thoughts about what that plant was. What this plant is really called is, for short, it's called SONGS, or San Onofre Nuclear Generating Station. Now, the tragedy that happened in Japan didn't shed most light on nuclear power on a positive light, but America, comparably to Japan, has a very safe nuclear record. The biggest incident that America has had was in the 1970s was 3 Mile Island, and after that we hadn't had any major incidents since. But through sources from the U.S. Department of Energy, the U.S. Nuclear Regulatory Commission, General Electric Manufacturing Company, and Hitachi subdivision of General Electric, I'm going to talk to you today about the principal basic operations of nuclear energy and the safety standards set in place by the U.S. to maintain this safe source of energy, which unregulated is extremely dangerous, which we've seen in other countries. Now, what I'm going to talk to you today about is the basic principles of nuclear theory and operation of a standard nuclear plant. I'm also going to explain what a meltdown is and what safety practices are in place to prevent this type of catastrophe. Now, as you look at visual aid to your left, you will see that there is a teapot on top of a hot plate. Now, the hot plate represents a reactor which emits an exothermic reaction, which in turn boils the water in the teapot. The water inside the teapot begins to boil and it creates steam. Steam inside the teapot forces out through the orifice in the spout of the teapot, in which in turn drives the turbine, which circles around at a predetermined amount of speed, and which in turn drives a generator, which through the revolution of the armature created by the turbine is going to create an electron flow, which is in turn going to create electricity. Now, once this is accomplished, your power is going to flow through the transmission line and is going to illuminate the power source or the light bulb on the visual aid. Now, the principle behind the reactor is basically a reaction between two elements, such as uranium, boron, and graphite. In a particular water boiling reactor, you're going to have what we call control rods, which are submerged in a coolant solution of ethylene glycol or a similar type of heavy water coolant. Now, this coolant was an intermediate area to transmit the heat energy from the reactor into another heat generating source. So when this coolant is circulated through the reactor, it's going to go to a steam generator, which is a closed loop style of system, which prevents the radiation from leaking out into the atmosphere. Now, the uranium inside the reactor is encased in individual steel tubes with pellets, probably no bigger than my fist, inside this. Now, these have a half-life of particularly around 2,000 years still radioactive. Now the actual useful life in a plant can be anywhere from 5 to 10 years, depending on the size and the use. Now at San Onofre, it's basically a wet cell or boiler type reactor. Now, with the reactor, there are many different styles in which they're arranged. But for the most part, most nuclear reactors in the U.S. are the wet type, in which a coolant solution is circulated around the core, in which it's circulated into a heat exchanging element, in which that's heated and then circulated into the turbine, creating a non-irradiated water solution. Now, the next point I'm going to move on to is we're going to talk about a meltdown. A meltdown is the worst case scenario for a reactor in which the actual control rods or the pellets inside these steel tubes have become deformed and have lost control, are basically in an uncontrolled fusion reaction in which the core becomes superheated and these rods actually liquefy into a magma state. Now this magma state is very hazardous to the environment around it because of its superheated nature. It has a tendency to melt through concrete and other elements because of its inherent heat, and it has a tendency not to stop until it hits an aquifer or groundwater, which has a tendency to contaminate local drinking waters and other aquifers. Now, before this usually happens, there's multiple reasons why the core fills and melts down. Now, that coolant around the reactor core and stuff keeps it at a very steady temperature, depending on the load of which the plant operates. Now, the coolant itself, without the coolant, the rods cannot maintain a normal balance of power. So this leads me to my next point about the safety that is in place. Each reactor has sensors that are located inside of it to measure actual coolant temperature and water and coolant level. Now the coolant level inside of the reactor is constantly monitored and constantly rotated and made sure it meets specific regulatory means. Some of the major issues that have arisen in the past have been leaks from pipe fittings, welds failing, and so on and so forth. Now, the inspection of these plants usually involves X-ray of welds, inspecting of joints, pipes, and other valves and entities. Every single one of these parts is serialized by manufacturer, date of installation, and also who installed it, what its actual shelf life is. A lot of these parts and stuff will be with the reactor for the whole cycle of the plant. Most of them will be replaced over a certain amount of time and depending on where. Now, also in this speech, I've talked about the basic functionalities of a power plant. I've talked about worst case scenario, a meltdown, and then I've also talked about some of the safety features of the nuclear power plants. And that concludes my speech.